Hello, my name is Clifford Jordan and I'm with Science Foresight, and we're going to talk today about what we call the slope-intercept formula. And this is part, like a prerequisite for a course that I'm teaching on linear regressions, which is the first course in data science. But before we can actually get into the depth and the hard to understand linear regressions, you really need to understand the slope-intercept formula. Now, you've seen this before. You may have seen this actually in high school, either in algebra or maybe algebra or geometry class. But it has this formula, a y equals mx plus b, where m is equal to the slope and y, or b, is equal to the y-intercept. Okay, so what we've got here is what we call a Cartesian plane. We've got two axes. This is the y-axis, and then along the bottom here, this is the x-axis. And then the blue line is just a line that we've drawn that we want to map out. So we want to figure out what is the formula for this blue line. Well, this is the general case of the formula, and what we specifically want to figure out is what is m and what is b for this particular blue line. Okay, and so we're going to end up with something that looks like y is equal to some number times x plus some number. Okay, so we need to figure out what those numbers are. Let's start out with the easy one. The easy part is b, the y-intercept. Okay, so if you follow this blue line all the way down, the y-intercept is where that line crosses the y-axis. Okay, and we know that this is the case because this is where x equals 0. So when x is equal to 0, we go up, and where that crosses, that's the point. Now in this particular case, that's 2. Now from a formula point of view, let's look at it there. When x is equal to 0, that means x is equal to 0. 0 times m is 0, so y is equal to b. All right, so if x is equal to 0, we see here that y is equal to 2. All right, so b must be 2. All right, so to remember that, what I'm going to do is, real quickly, just kind of draw right here, say, we're going to type in 2, okay, just so we remember that. Okay, so the next thing we need to do is we need to figure out what m is equal to. Now you may remember from back in the day when you had algebra, people, well, I don't want to type it right there, let's get rid of that the slope is equal to the rise over the run. Do you remember that? Slope is equal to rise divided by run. Okay, and what is the rise? What is the run? Well, the rise and the run are simply, let's draw a couple little lines here. This distance coming down, and let's get rid of that. Just put one thing here. Okay. This is what we call the rise, this distance from here up to here, and this is what we call the run. Okay, so what I'm going to do here is just go ahead and type that in. This is the run. Let's get rid of that. There we go. And then over here, this is the rise. All right. So this is what we call the rise and the run. So you choose any 2 points. We've chosen these. And so this distance here is the rise. And it turns out, in this particular case, that rise is equal to 1 going up and then 2. All right. And for the run, it's going from this point here all the way over to this point. So it's 1, 2, 3, 4. Now you got to make sure that indeed this is at point 6 on the x, and then 8 on the x and 6 on the y, and this is at 12 on the x and 8 on the y. So from between here and here is the difference between 12 and 8. So that difference is indeed 4. So you just got to make sure that the numbers down here correlate to the number of boxes you're counting over. So we got the run is equal to 4, the rise is equal to 2, so the slope is equal to 2 divided by 4, and I'm sure you remember that 2 divided by 4 is equal to what? 0.5, or 1/2. 0.5. So what that means is that is our slope. So now that we have that, we can write the formula. We're going to write it as y equals 0.5 x times x plus 2. Okay, so because we know that 0.5 is the slope and 2 is the y-intercept. So there you go. That is the formula that describes that line. Let's go ahead and test it out really quickly with a couple extra points. Okay, see if they're on the line. So for example, notice that here's a point over here. Let me put a little dot there. This is at 2, where x is 2 and y is equal to 3. So let's see if that point, 2, 3, is on the line. So if x is equal to 2, 0.5 times 2 is 1, right? Plus 2 is 3. So 1 plus 2 is 3, so y is equal to 3. So when x is equal to 2, y is equal to 3. Let's choose another point up here. Here we go. This is 16 and 10. So 16 on the x and 10 on the y. So if x is equal to 16, 1/2 of 16 is 8, plus 2 is 10. So sure enough, this point is also on that line. So this is just a way of double checking or triple checking that this equation, y equals 0.5 x plus 2, accurately defines this line. Okay, so there you go. Now what we're going to be doing in linear regressions is we're going to be looking for the line. Excuse me, let's go this way. We're looking for the line that is kind of what we call a trend line. To explain what a trend line is, let me pop over to a spreadsheet. And we're going to look at what we call a scatter plot. So here we go. Here is some data, and we've got ourselves a nice scatter plot here. So this data here is these two columns, and there's like 84 different examples of these, or 84 different rows, let me say that, of those columns. And what they are is each row is a purchase date of when someone came into the store, and then the coupon value here in this column is the coupon that they redeemed. So we see from this first one, on the 16th of January 2016, this guy redeemed a coupon of $7, and his total purchase amount was $115.61. So all 84 of these are different per days that they came in and redeemed a coupon, and then you see how much they purchased. Now notice that some of these have 0 coupons. Yeah, I mean, this guy didn't redeem everything every day that he came in. Some days it was just 0. But what does all this data really mean, and why is it important? Well, if I've got a store and I'm giving out coupons for people to come in and purchase stuff at the store, I especially want to target those clients that when they do redeem a coupon, they spend more than they would normally spend when they don't redeem a coupon. And in fact, I would love those clients that spend more. So in other words, the greater the coupon, the more they spend. Those are like the perfect clients. This client here, that this data represents, is exactly like that. So this is a really good client. So what we're going to do is we created a scatter plot where we took all 84 of these different values of x and y, and we plotted them on this graph. Okay, each point here represents one of these dates. So this one is $7 coupon and $115 of total spend. The y-axis is the total purchase or total spend, and the x-axis is the coupon value. So a coupon value of 7 and 115 on the y-axis. So if we go over here to 7, here's 7. If I go up here and just look at each one of these little dots on the 7, there it is right here. So notice that what just got highlighted is this particular spend. He has an x value of 7 and a y value of 115.61. So this is where that dot is. Each one of these rows has a dot here. And then what we did is we created this really nice blue trend line that's right in between. And how did we do that? Well, let me delete it and show you. So let me delete that. And to create it in Excel, all you do is right click on any of these dots. You see it says down here, add trend line. So I'm going to add it. And it's not as big right here, but let me see if I can make it just a little bit bigger. There we go. Made it a little bit bigger. Let's go back. And this time I'm going to also display the equation. Okay. And you probably didn't see that, but let me move things around. Move my mug over here. Come on. There we go. So if you click this little thing over here called display on Trendline, okay, and then what that does is it creates this nice little equation right up here. And let me boldify that and make it bigger so you can see it. And guess what the format of that formula is? Well, it's just like we saw before. Y equals mx plus b. Okay, so m, the slope, is right here. Okay, it's 3.5798, and b is 96.824. Now, hopefully you're asking the question, Cliff, that's cool, but what does that really mean? And as I make my mug a little bit easier for you to see, let me explain what that really means. That slope is the rise over the run, and the rise is the total purchase. The run is the coupon value. So think of that as $3.57 or 58 cents per $1 of run. Okay, so that's $3.58 of rise for every $1 of run. Okay, so if the rise over the run is 3.58 divided by 1, that's 3.58. So what this means in this context, in the context of this data, is that if I give this guy a coupon of $1, he's going to give me extra of $3.58 on average. Okay. If I give him $2 coupon, he's going to give me twice that. Okay, so that'd be $3, almost $7, a little more than $7. If I give him $3 coupon, he's going to give me 3 times that in extra revenue when he spends at the store. So that's what that slope means. Now, what does this $96.82 mean? Well, what that is, that's the y-intercept. When x is 0, and x, remember, is the coupon value, so if I don't give him a coupon when x is 0, that means he will spend on average $96.84. Okay, and remember that is the y-intercept. So if I follow this trend line all the way to the y, which is right here, it crosses the line right about here, which it's maybe kind of hard to see, but that's right there at 96.84 or 82. All right, so that's the y-intercept. Like I said, what that means is when he has no coupon, on average, he spends $96.82. And then when I give him a coupon, the amount that he's going to give me back, on average, would be the value of the coupon times this slope. Okay. That said, notice that not all these purchases that I have, they don't fit on that blue line. Why? Because, customers are not perfect. They have variance. Sometimes they'll spend a little more, sometimes they spend a little bit less. If they see something they like, they spend more. They see something they don't like, they spend less, whatever. So there's always a little bit of variance, okay? So that's why they're up and down. They're not on the blue line. But on average, if I average everything out, they will fall on that blue line. Okay, so if I average out all of these, it should be very close to the blue line. If I average all of these, and if I average these, it all basically approximates the blue line. So in this particular example, for the long game, if I was the owner of the store, I would say, hey, this is a good customer. The more I give him a coupon, the more he's going to spend. So give this guy more coupons. Send it to him in email, send it to him on a text message, or as soon as he walks in the door, if I can identify this customer, give that guy a coupon because he's going to spend more when he redeems that coupon. So this is the type of customer. Now, I can't tell on any one trip that he comes to the store that he's actually going to spend more on that trip. I can't really predict that very well because there's a lot of variance in there. But in the long term, on average, yes, he will. So if I'm playing the long game, give him those coupons. So there you go. This is a story about y equals mx plus b, and how it applies in a real life situation. Hopefully you understand. Continue on. The next thing we're going to talk about is probability distributions, which is also required understanding before we get into linear regressions. Talk to you then.